Welcome back, ladies and gentlemen. This is Dr. Robinson again, and we're going to continue our studies. This time we're talking about accuracy and precision. Accuracy is how close a measurement is to the actual value. Please note, the greater number of significant digits in a measure, the more accurate the measure is. Hopefully you saw my video on significant digits so you can know what we're talking about, but we will go into it. The accuracy of a measure of the number of significant digits is in the measure. So the accuracy is just the total number of significant digits, and we'll talk about what a significant digit is. Here's something that you might want to find interesting. When measures are multiplied, the products can be no more accurate than the least accurate of the given values. Make sure to keep at least one more significant digit in the intermediate results than is needed in the final answer, because you have round-off errors that occur when you discard information that contains extra digits. This will skew your calculations. So unfortunately, we're not going to talk about that this year, but that's a good note for hopefully next year. All right, precision. Precision, how exact or reproducible a measurement can be. Note, it refers to the level of exactness that a given measuring tool can deliver. The precision is the measurement. So precision of a measurement is the place value of the last significant digit in the number, and that's important. It's a place value. So of the, again, significant digit, it's the last one in that number, and we'll talk about that. If the place value of the last significant digit is smaller than another in comparison, it's more precise. So when measures are added, by the way, the sum can be no more precise than the least precise number of the given values. So that's good to know also. And greatest possible error, GPE, of any measurement is defined as equal to half of the place value of the last significant digit. Here's an example. If you have a pen that's 6 inches in length to the nearest inch, the greatest possible error in measurement is 0.5 inches, and the actual length lies somewhere between 5.5 and 6.5 inches. The real interval of measure is 6.0 plus or minus 0.5. That's how the error is. It can be 6 minus 5, which gives us 5.5, or 6 plus 5, which gives us 6.5. So that interval can lie anywhere between the lowest amount and the highest amount, 6.5 and 5.5. The smaller the unit of measure, the smaller the greatest possible error, and the more precise the measurement is. All right, so let's get into it. Here's a chart I created that'll help you out with this topic. So here we have hundreds, tens, ones, decimal point, tenths, hundreds, thousands. We have accuracy, which is the number of significant digits. Precision, which is the place value of the last significant digit. GPE, greatest possible error, which is the place value, which is this column here. The second column, like 100 is 100, 10 is 10, 1 is 1. There's your decimal point. 1/10 is a fraction. It's also 0.1. 1/100th, which is also 0.01. 1/1000th, which is 0.0001. So we're going to multiply that by 0.5, or a half. So if you remember significant values, you look at the number of items in there and count them up. If it has a decimal point, you can count those values too. So 1, 2, 3, 4, 5. So that would be 5 significant digits, which would be the number that the accuracy as well. So 5 would be the number of significant digits. Now for precision, it's the last place value. So if we go to the last number in 150.02, the place value is hundredths. So the 2 is in the hundredth column, so the precision would be hundredths. So now we're going to take the hundredths column, which is 2, and multiply it. I'm sorry, we're going to take the hundredth column, which is 1 over 100 or 0.1, and multiply it by 0.5. So we get 100 times 0.5. That'll give us thousandth, 0.005. So now we're in the thousandths column, 0.5, 5,000th. So we're taking half of this place value. So that's why I use that and not the 2. So I don't use the 2, I use the place value, PV, place value, times 0.5. We take half of that. So let's try another one. All right, let's look for the significant digits. Remember, it has to have a decimal point in order to count these zeros. There's no decimal point, so we cannot count these zeros. So there's only one number we will be counting, that's the 9. So it has only one significant digit. So the accuracy would be 1. And now let's get the precision. So look at the significant digit. We're looking at the last significant digit. Now I know you're tempted to say, hey, 1s would be the significant digit, but no, the significant digit was only the 9. The zeros don't count in integers. So 9 would be the significant digit, and that place value would be hundredths. Now let's take the hundredths column and multiply that by 0.05. So we're just taking half of 100, and that would give us 50. So the error would be plus or minus 50. So 100 would be the precision, and it'd be plus or minus 50. So it'd be between 850 and 950. So let's look at our next one. We have 0.003. Now we do have a decimal point, but we have all these zeros preceding it. And if you remember in significant numbers, we cannot use the preceding zeros. So we only can use the 3, and that's just one number of accuracy. So sorry, I know you wanted to use these zeros, but check out that video on significant digits I made, and you'll see that it's only one number that we can use. So the 3 is the only one. So the place value of the 3 is in the thousandth. So that's the precision. Now we're going to take that place value, which is either 0.001 or 1/1000, and multiply it by 0.5, and that'll give us 10,000. 10,000, 0.00005. So you're getting pretty good at this, so let's see if you can try the last one. So we got 3.0. So take a second. What would be the accuracy? Remember, you have a decimal point. So if you said 2, you're right. 2 numbers, because you have a decimal point, you can include the 0. And what's the precision? And precision, if you said, hey, there's the 0, so I'm including it, and it's in the tenths place, you're right, tenths place. Now you're going to find the GPE, greatest possible error. So you're going to take that tenths place and multiply it by what? 1/2 or 0.5, and that'll give you hundredths, 500ths, 0.05. So if you got that right, great. So check your understanding, see if you understand what's going on. If you don't understand it, rewatch the video, write down your questions, bring them in tomorrow. So I have a few questions for you. So state the accuracy of 12.0 feet. If you remember accuracy, that's just a number of significant figures we have. So let's see, we got 12.0. So I have a decimal point. So there are 3 numbers here. So that makes this 0 included in my answer. So that would be 3. And 3 is correct. So it's just a number of significant figures. So here's one for you. State the accuracy of 5.042 centimeters. Here's another one. State the accuracy of 93 million miles. Check your understanding, of course. State the precision of 5.042 centimeters. Remember, precision is the last place value in the number. So we have to include all of these digits because it has a decimal point and the 0 is captive inside this number. So we're including the 0, so 2 is the last place in this value. So what place is it? We got tens, hundred, thousand. So I'm going to grab C and drag that up here, and there's my answer. So thousands. Remember, that's the last place. If we wanted the GPE, the greatest possible error, that would equal to the number place value of 2, which is 1,000, and I'll put it this way. 1, 2, 3. Oh, sorry. Let me erase that. 0, 0, 1. All right, and multiply it by half, by 0.5. That would give me 0.0005. And I can put a 0 in the front here, or I can put 1, 1,000, and multiply it by half, so that way you can see the fraction. And 1 times 1 is 1. 2 times 1,000 is 2,000. I can use that as well. So, and 1 over 2,000, if you want to reduce that, 1, and divide that by 2,000. Watch all these zeros here. Add a few zeros. 2,000 goes into that. 0 times, put my decimal point into 10. 0 times into 100. 0 times into 1,000. 5 times. And did I do it right? I think I messed up with a 0, so let me hold on a second. It'd be nice if I had my calculator, so let me just pause for one quick second. Okay, I see I left out a 0 there, so let me fix that. So let's put that 0 on there, and 0, 5. And let's make sure, get my calculator up. So I got 1, ABC button, 2,000, and now press enter. There is my answer. 0.3 zeros and a 5. So that would be the precision of that number. So we need to make sure that when we're looking for the GPE, that we just take the place value and divide it by 2, or multiply by 1/2, or multiply by 0.5. So that's precision. So here's one for you. State the precision of the 12.0 feet. So try that one. Here's another one. State the precision of 93 million. Check your understanding. Which one of these is more accurate? Well, if you remember accuracy, that deals with the number of significant figures. So the first thing I would do, I would try to find out how many significant figures I have. Now, there's no decimal point in this number here, but it does have 3 digits that are not 0. So there would be 3 significant figures here, and I'm comparing it to, well, this has a decimal point and it ends in a 4, so I can definitely don't have to worry about 0, so that has 2 significant figures. So which one is more accurate? Well, I'm going to grab A because it has more numbers. So that's more accurate. So here's one for you. Which one is more accurate? Take your choice. Remember, how do we find accuracy? Based on significant figures. Now, which one is more precise? If you remember precision, we just worked a problem out about that. It's the last value that we're going to deal with and look at it, and we're going to multiply it because this is in the ones. That's in the ones, and we're going to multiply it by 1/2. If we multiply that, we get 0.5, or 1/2. Now, if we look at the last significant digit in this one, is 4. That's in the tenths. And let me write that down. 0.1, and I'm going to multiply that by 0.5. And I get 0.05. Because 1 times 5, and I'll do it this way. 1 times 0.5 is 5. And there are 2 numbers behind the decimal point, so I got to have 2 numbers behind my decimal point down here. So that's how I get 0.05. So I'm going to say B because it has more preciseness, and it's more closely related. If you take a look at precision, 6.4 feet has a smaller error range here, so it's more precise. Remember, the more smaller the error, the more precise the measurement is going to be. So you have to remember how to figure out precision. So here's a chart on some significant figures. So hopefully you'll find it right. If you need to go back to my video to watch it, remember it's just a number of items that are in the accuracy as well. So hopefully you remember that. So accuracy, significant figures are the same. So hopefully you said 2 for that one. And here's a cute one. If you said 2 for this one again, you were great. So remember, check out significant figures. It's a good video. Here's the last one. 9,007D with a decimal point on the top. Wonder how many significant figures is that? So check out the other video. I hope you found this lesson interesting and hopefully helpful. So write me. If you have questions, give us a thumbs up on YouTube. If there was some difficulty, write down your questions, bring them in the class. I'll be glad to answer them. Thanks so much for watching, and keep us keep giving us thumbs up in the work that we're trying to do for you guys. See you in class. Bye-bye.